A warm welcome to today's lesson where we are continuing with set theory. Now the first video in this series, I'll pop a link in the top right hand corner for you, and in that video we looked at set, universal set, empty set, set membership, intersect, union and complement. So the focus today is on subsets. Now when I look here, I've got set A. It's got elements 1, 2, 3, 4 and 7. Underneath, I've listed 3 more sets. Let's have a look at set B. The elements in set B are 1, 2, and 4, and those elements are contained in A as well. So what we can say is that B is a subset of A. And when we look at that notation, it looks a little bit, I should remind you, of the less than or equal to. We'll come back to that in a second. Let's have a look at set C. We've got 1, 3 and 5. Well, 1 and 3 are contained in A, but 5 isn't. So C is not a subset of A. And when we look at D, all of these elements are contained in A. So yes, D is a subset of A. This sort of raises a question. Well, if D has the same elements as A, we know that D is equal to A, and this is where this equals comes into it. So in other words, we could say that A is a subset of A. A is a subset of itself. Seems a bit strange. So when we go back to set B, well, this doesn't contain all of the elements of A. In other words, this is not equal to it. It is a subset, but it's not equal to A. So in this case, what we can say is that B is a proper subset of A. So that briefly covers subsets. What about supersets? Well, that just means flipping it over. So if B is a proper subset of A, what we can say is that A is a proper superset of B. So we've just flipped that thing over. When we go down to here, what we can say is that A is a superset of D. Let's have a look at another example. Let's say I have a set E. And in my set E, I have elements A, B, C, and D. Let's say I have a set F. And in set F, I have A and B. And I have set G. Let's say that contains B, C, and D. We can also have H. That could be B, C, D, and A. And then we could have J. Let's have J equal to A, D, and E. Okay, well, let's look for subsets, proper subsets, and supersets. So what we can say here, well, F has elements A and B, which are contained in E. So what we can say is that F is a subset, a proper subset of E. It is also a subset, but it's a proper subset. G, well, B, C, and D are also in E. G is a proper subset of E. Let's look at H. Now H contains the same elements as E. They're in a different order, but that doesn't matter. So H is a subset of E. And then J, well, J contains this element here, E, which is not in set E. So J is not a subset of E. Okay, well, let's have a look at supersets. What we can say here is that E is a proper superset of F. E is a proper superset of G. We've got E is a superset of H, and E is not a superset of J. So hopefully that makes sense. Let's just go back over it again here. With this F set here, it is a subset of E. It's also a proper subset of E. G is a subset of E. It's also a proper subset of E. Now H is just a subset of E. It is not a proper subset. In other words, this one is equal to E. And obviously J is not a subset. Let's have a look at another example. So I've got set A here with some even numbers in 2, 4, 6, 8 and 10. Let's have a look at set B. The elements in set B are in set A. It is not equal to set A. It is a subset, but it's also a proper subset of A. So B is a subset of A, but B is a proper subset of A. In set C here, we have exactly the same elements in C and A. So C is equal to A. So what we need to say here is that C is a subset of A. We can't say that C is a proper subset of A. So C is not a proper subset of A. D contains one element. D is a subset of A. D is also a proper subset of A. Now E is the empty set. The empty set is a subset of every set. So we can say that E is a subset of A. We can also say that E is a proper subset of A. And when we look at F, we see we have this element 1 here, which is not part of A, and therefore we can say that E is not a subset of A. And likewise, we can say that E is not a proper subset of A either. Let's have a look at this with a diagram. So let's have this universal set. In here we have set A, and in set A we have 2, 4, 6, 8 and 10. Now what we can do, we can see set B is 2, 4 and 8. So here we have set B. And as you can see, set B is contained within set A. So therefore it is a subset. It's a proper subset. Let me just draw this again. So again, we've got the universal set. We've got set A. And then we've got 2, 4, 6, 8 and 10. Now this time let's have a look at set F, which contains 1 and 2. So set F would need to look something like this. So this would be set F, and we would have 1 in here, and obviously 2 is also a part of A. So this is not within A. It is not a subset of A. The last thing that I'll touch on is something called the power set. What is the power set of A? So P of A. What is the power set of A? The power set of A is a set of all the subsets of A. Well, the first subset we can have is the empty set. Remember, the empty set is a subset of every set. We could then have a set containing just A, a set containing just B, and a set containing just C. We could also have one containing A and B. We could have one containing A and C. We could also have B and C. And then the last one is the set A, B, and C. And then just finish off with that final curly brace. If you found this video useful, then remember to give me a quick thumbs up. And if you would like to be notified when I release new videos, then hit that subscribe button and remember to click on the little notification bell.